Hello, everybody. We're here for part three of our TSI review. Our part three will be composed of simplification and expansion. Simplification, basically, you should think about it as to combine like terms. And when we talk about expansion, is basically we got to go and apply distributor property. So we're gonna do a couple of examples and see if we can make some connections. This is something you do all the time already. Let's see if you guys can get the questions correct. So let's go ahead and get started. This first question right here. All right. So we gotta combine like terms, but before I can combine like terms, I gotta get rid of those parentheses. So I gotta make sure I distribute that -5 into this. So -5 times x is -5x. -5 times 3 is -15. The other one, I'm just gonna go ahead and bring it down. Voila. Combine like terms. 2x minus 5x is -3x. Keep in mind, you will probably not have a calculator for the TSI. It pops up a calculator here and there, but in most cases, you won't have a calculator. So you got to be able to do this by yourself. -4 plus -15, same sign. Adding, keep the sign. So 4 plus 15 is 19. And I can't combine it anymore. That's my final answer. So you've done this before. Let's go to this question down here. Send my idea. Now I wanted to talk about this one because usually most people mess up here when there's only a minus in between. You see how there's a minus in front of the parentheses? We have to distribute that negative into both parts of the parentheses. So negative times 5x is -5x. A negative times 1 is -1. If you could think about it, when you see a negative in front of parentheses, basically we're switching the sign of everything. And the other part at the beginning, I'm just going to go and bring it down. Combine like terms once again. 8x, I combine with -5x, that is 3x. And then -2, I combine with -1, -3. That's my final answer. So you've done this before? Here we go. Oh, we're gonna expand this. We're gonna go and apply distributor property, and we want to make sure that you guys got this on point. We are gonna multiply this times the first term of inside the parentheses. Now we're gonna go and multiply first 4 times 8. What's 4 times 8? 32. Then we're gonna go into x cubed times x squared. Remember your laws of exponents, right? We're multiplying bases that are the same. So what do we do to the powers? We add them. When we multiply, we add the powers. Now let's go look at our next part. Here is y7, y5 times y. We have y to the power of, you said 6. You're correct. Don't forget that there was a little 1 there. And we're going to do the same thing to this one. So I'm going to erase this. Now we're going to multiply times this one. Right? So let's go ahead and do multiply -4 times that -7. 4 times -7 is -28. And right here we have x cubed. There is no x's on this other term. We have no x's here, so we're just going to rewrite whatever x we had there, x cubed. And then we're going to go ahead and add the power y5 times y cubed. It is y to the power of 8. Now, very important question. Can I combine these two? The answer is no. This is x5, y6. In order for me to be able to combine things, they both have to have the same powers to the same exponents. They're both different. This is my final answer. Voila. Now let's go and look at this. A binomial times a binomial. We've done this plenty of times before. Maybe it's been a while. So I'm putting this right here so you can make sure you see it. X times x. X squared. X times 7 plus 7x. Negative 1 times x. Negative x. Negative 1 times 7. Negative 7. And if you did that, voila, you have finished expanding this binomial. Now let's go ahead and simplify it by combining like terms. What terms can I combine? These two. Don't forget there's a little one there. So it's x squared plus 6x minus 7. Voila. So right here we were simplifying, expanding, and then we have right here one more to expand. This was important. This is a power to a power scenario. So what I mean by that, we have, and very simple to see, a4. Then outside we have another power. So power to the power, what do? Multiply. Now keep in mind, all of these actually, variables each individually has a power. The numbers have a power as well. So when we do a power to the power, we're technically going to multiply those powers times the outside power. So this question is very simple. It's going to be 3 to the power of 2. 8 to the power of 4 times 2, which is 8. B to the power of 1 times 2, which is 2. Then n to the power of 2. All of it divided by 5 to the power of 2. This is technically correct. Most likely, though, you're not going to see this answer. You'll probably see 3 squared, which is 9, A8, B squared, N squared, all divided by, what's 5 squared? 25. It could be that they show it to you like that. Hey, who knows? I don't. Okay, haven't seen the TSI myself, so trying to get you ready as much as I can. Keep in mind, those two are equivalent. Last but not least, find the area of a rectangle, right? They didn't give me numbers, they gave me expressions. So how do you find the area of a rectangle? Area is equal to length times width. Or width times length, right? It's the same thing. You guys choose however you like. I personally, whenever I see this, I want to put the monomial first. So 2xy cubed. I'm going to put the binomial second. It's just more appealing to my eyes. So here we go. 2 times 4, 8. Then x times x squared. X to the power of 3. There was no y, bring down the y. Then 2 times negative 5, negative 10. X times x, x squared. Y cubed times y, y4. Can I combine these? Nope. That is it. This was a little bit of simplification and expansion.